So really, perovskite with silicon is actually a very good match. I think what sets Swift apart from these other companies is that our approach is really vertically integrating and bringing together the perovskite and the silicon at the cell level. So we can make a drop-in replacement for the cell that is just higher efficiency, right? And it's the cell drops into the module and you can make a more efficient module without really changing the rest of the supply chain. And uniquely, we have the silicon technology from Meyer Burger, the capability to build both the bottom cell and the top cell and the module.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more. Hey guys, are you a residential solar installer doing light commercial but wanting to scale into large C&I solar? I'm Tim Montague. I've developed over 150 megawatts of commercial solar, and I've solved the problem that you're having. You don't know what tools and technologies you need in order to successfully close 100 kW to megawatt scale projects. I've developed a commercial solar accelerator to help installers exactly like you. Just go to cleanpowerhour.com, click on strategy, and book a call today. It's totally free with no obligation. Thanks for being a listener. I really appreciate you listening to the pod. And I'm Tim Montague. Let's grow solar and storage. Go to Clean Power Hour and click strategy today. Thanks so much.
The clean energy industry is moving fast. The deals are getting bigger, the technology is evolving, and the stakes have never been higher. Welcome to the Clean Power Hour, the podcast for solar, storage, and microgrid professionals who want to stay ahead of it all. Each week, your host, Tim Montague, industry advisor and president of Clean Power Consulting Group, brings you unfiltered conversations with the leaders actually building the energy transition. Now, here's your host, Tim Montague.
Today on the Clean Power Hour, unlocking the full potential of the solar industry. As you, my listeners, know, I'm passionate for the clean energy transition that society is going through globally. And on the one hand, we have the technology truly to green the grid globally today. PV is very good, but it has limits. And we are developing newer and better technologies. My guest today is Joel Jean. He is the CEO and co-founder of Swift Solar, a tandem PV manufacturer based in California. Welcome to the show, Joel.
Thank you so much. I appreciate it.
I am a geek for technology, and I can't claim to understand exactly, how PV technology ebbs and flows. We've seen technologies come and go, and there is a rising tide right now of tandem PV companies globally and in the U.S. And I've had a couple of these companies on the show. If you are so inclined, go to cleanpowerhour.com and search on Caelux, Caelux, with Scott Graybiel, episode 223. We also had Cubic PV, Frank von Mierlo, episode 53. And what we're talking about here is a technology called perovskites, which Joel is going to explain for us. But Joel, for our listeners, tell us a little bit about your background and how did you end up starting Swift Solar?
Yeah, sure. Thanks, Tim. I started the company after being a solar researcher for about a decade. I did my PhD at MIT working on next generation solar technologies, a bunch of new crazy weird materials like quantum dots and organics and ultimately perovskites. And all these materials were, we explored these with a similar goal of trying to make more efficient, more easily deployable, lower cost solar, against a backdrop of silicon PV prices dropping like a stone, right, for many years, with scale and efficiency and all this. So you've seen that kind of trajectory. And after my PhD, I started a research program at MIT that was really focused on developing these kind of new solar technologies for developing country off-grid applications, places like India, where maybe you have villages that had no electricity at all during this time, and we were looking at how do you bring kind of lightweight, maybe deployable, flexible solar panels to folks who need that for water pumping, for agriculture, right, or for clean water. So just kind of unconventional use cases that could be really benefiting from a different form factor for solar, a solar panel that could be rollable, for example.
Mm-hmm.
So we looked at these applications. We explored perovskites as a key kind of next generation technology that could fulfill these needs. And then a couple years in, I spun out Swift with my co-founders. We were all a bunch of scientists early on from a bunch of different universities and institutions. So we all came together under the umbrella of Swift to really commercialize what we call this Perovskite Tandem technology, because we really saw this as the future of solar writ large.
I love the concept of, flexible solar, a rollable solar panel, or a roll of solar panel. Like, think of landscaping cloth, that comes in a meter wide roll, and you could just roll that out on a backyard, on a field, on a roof in so many ways if it were in that form factor. But so why don't you set the table a little bit in terms of how Swift is currently going to market? You recently acquired Meyer Burger, or some of Meyer Burger's assets. And when I hear the name Meyer Burger, I think this is a company that makes high quality, premium HJT solar modules. And now you're combining forces and brain cells. You've also acquired both Gunter Erfurt and their CTO, but paint us a picture for what's possible and how this is going to evolve in the near term.
Yeah, thanks for asking that. I'm glad you think that when you hear Meyer Burger. That's a good sign for us, I think. But maybe to take a step back, like to put in perspective, right? Like we started the company focused on these perovskite tandems, right? And a core part of that, maybe to put it into historical perspective, we've seen the solar industry kind of move through the sequence of technologies, right? And I'm a technologist. I always go back to the technology. Like we've had, aluminum back surface field technology. It's moved on to PERC and now TOPCon and HAT and back contact. And this progression has always happened motivated by improving efficiency, right? So every time you have a technology that can, passivate the silicon better and add a couple % of absolute efficiency, the industry just moves wholesale into that, right? So we saw everyone shift from BSF to PERC onto passivated contacts. And that progression has been driven by, say, 1 to 2% of absolute efficiency gain. And of course, that improves costs, that helps with LCOE, helps with returns. So everyone does want that kind of improvement in efficiency. And I think what sets tandems apart, right, perovskite tandems, apart from all of the other thin film technologies that have sort of come and gone, right? Whether that's CIGS or organics or other dicels or other kinds of technologies you might hear about. The reason tandems are unique is that they can actually break through that efficiency limit in a way that none of those other technologies could. So we've had silicon for 7 decades, right, since the 50s, and it's kind of continued to push up efficiency to now 28% record cell efficiency. And there's never been a new technology that could actually outperform silicon and be competitive on price. And tandems uniquely for the first time, right, can do both. It can be higher performance and as cheaper, right, from a cost standpoint. So that combination is unique, and that's why I see this as a kind of a real step change opportunity for the industry. I think that's where the manufacturing side of the industry is moving.
So PV is approaching the Shockley-Queisser limit, though, right? That
Yeah.
limit is a physical limit of 29.5% approximately. And
Yes. Yeah.
and so we're now going to push through that in a way, but only by combining technologies, different technologies, right?
Yes.
And in your mind, what is the goal of Swift Solar in terms of this efficiency, and how does that translate into what's possible from a market perspective, and achieving your goal, which is to bring low cost solar to the masses?
hmm Yeah, that's a great point. So the 29.5 or so percent limit is fundamental to any single, silicon-based technology. With any single solar cell, it's around 30%, similar kind of limit. And it's only by stacking two different materials, two different solar cells, that you can break through that limit. So in straightforward terms, like with one cell, you can do 30%. With two cells, you can do 45%. With three, you can do about 50. So you can continue to stack these up in the long term, right, and get to higher and higher efficiencies. And that is the only proven way from a physics standpoint that we've been able to actually boost the efficiency of solar beyond that single material limit. So that really mirrors how we think about the future of solar, right? Solar has always been about making, how efficiently can you convert sunlight to electricity? We can do it pretty efficiently with silicon now. The next generation is putting a perovskite layer directly on top of the silicon to make a two junction cell that can break through, 30, 35, potentially even 40%. And then adding another layer in the long term, three layers, you can then get to 40, 45% plus. So that's the progression of the industry. I mean, taking that really, really long-term view of, 1, 2, 3 decades, that's where we want to push. And that's where, Swift's technology, our approach, our team is really built around making those next generation technologies possible, starting with the perovskite on silicon tandem. And to your kind of final question, why does that matter? What it unlocks is, by having higher efficiency, not just boosting 1% or 2%, jumping 5%, 7%, 10% compared to existing technology, you get just transformative impact on how you deploy solar, on the economics, right? Because, for example, the land, the labor, the racking, all of those, you get more megawatts per dollar, per rack, per labor hour.
Mm-hmm.
So therefore, your overall system cost and your LCOE go down. So that's like the biggest lever we have in the industry to really improve the economics of solar.
And when you think about the types of solar modules that you're going to make in the near term, will they be targeting the utility, the C&I, or the residential segments of the market?
Yeah, our target initially is largely the utility and maybe large CNI and community type of installations. Reason being that when we talk about these tandems, we're really talking about technology that needs to gain field experience, needs to go through certifications, reach bankability, and that takes time, and it takes kind of forward-looking buyers who are buying, have a pipeline out 2, 3, 4 years. So that really kind of pushes us towards those larger scale markets where buyers who are really looking forward, thinking about how they de-risk their long-term pipeline. I think sort of back to the Meyer Burger acquisition piece, which we haven't talked too much about. What that really brings us is the opportunity to go broadly and just serve the market with a proven technology that's already fully bankable. And that opportunity, I think, is unique for Swift Solar, for us in the industry. For new startups, it's very rare that you have this opportunity to have a bankable technology from day one. Of course, it's not day one for us, call it day 10, right? We're 8 years in. But this opportunity came along, and I think it's perfect timing because we're right on that cusp of scaling up manufacturing. So bringing in Gunter, bringing in their Marcel, their former CTO, bringing in the kind of core cream of the crop of Meyer Burger, I think allows us to really bring together the best of European silicon manufacturing talent and technology and IP, and the best of US perovskites talent IP together to make the kind of the ultimate high efficiency Western solar platform.
And are companies like First Solar pursuing different technology? Because
Mm.
I'm sure they're doing R&D on some form of tandem as well, and they are a major player in the utility space,
Mhm.
and the largest, I think, individual manufacturer in the solar industry, albeit not PV, right? Their
Mhm.
technology is thin film, but and then maybe paint us a picture of where Swift is versus other tandem companies in the market right now.
Mhm. Mhm. Yeah, so First Solar, it's a good question. First Solar and other perovskite tandem companies, startups in the US are really focused on what we call a four-terminal tandem technology, where you put perovskites on glass and then stack that on top of a traditional kind of silicon module. And that's an approach that I think for sort of thin film deposition, thin film manufacturing makes a lot of sense. That's sort of naturally where First Solar comes from, right? They've been making CAD-TEL on glass for many, many years and really doing a great job in the market on that. Um, However, their approach of perovskites on their existing CAD-TEL technology is not going to be an optimal tandem from an efficiency standpoint, because CAD-TEL is not cadmium telluride is not a good semiconductor as the bottom cell to be paired with perovskites. It's just not well matched from a part of the solar spectrum it can absorb standpoint.
Yeah.
So it's not the best combination. So really, perovskite with silicon is actually a very good match. I think what sets Swift apart from these other companies is that our approach is really vertically integrating and bringing together the perovskite and the silicon at the cell level. So we can make a drop-in replacement for the cell that is just higher efficiency, right? It's the cell drops into the module and you can make a more efficient module without really changing the rest of the supply chain. And uniquely, we have the silicon technology from Meyer Burger, the capability to build both the bottom cell and the top cell and the module. So I think we have a very clear bankable path going from new technology to full scale bankable tandems. I think that's unique in the US industry.
And is there a bifurcation in the future? Because, hearkening back to a different form factor, a flexible solution, for example,
Hmm.
that perovskites perhaps offer, we're talking about layering perovskites onto rigid solar panels and making them more efficient. So yeah, you're getting more PVDC per square foot or meter, right? Or more more watts DC per square meter,
Hmm.
which in large scale applications really does matter. Not so much in like residential, because we can already completely solarize a home with existing technology. But if you
Hmm.
can make the LCOE of large scale solar lower, that will catch on. I mean, I don't know
Hmm.
what the critical increment is. Is it 5% or 10%? Yeah, just real quick, do you
Hmm.
see perovskites offering some alternative future in addition to this layered approach?
Yeah, absolutely. So I think on the efficiency piece, I think what you can get is even on the residential side, yes, you can, power the whole house with existing panels, but you can still reduce the cost per watt by having a more efficient panel, right? Because you need less roof area, less of the racking, and so on. Or you can
Mm-hmm.
get more watts out, right, and oversize it. I think that's another different kind of optimization. But back to your core question here, I think it's a good point that with perovskites, yes, you can make a tandem and make solar panels more efficient, and I think that's where the bulk of the industry is focused. There's of course an opportunity to make a flexible or a lightweight product that uses only the thin film perovskite. It omits the silicon altogether. And what that allows you to do is, like we talked about earlier, kind of create different formats, rollable formats,
Mm-hmm.
lightweight formats for deployment. And the I'll say that we started out the company started with the Swift Solar. We started the company actually working on those kind of lightweight, flexible formats. And the reason we moved away from that as a starting point was that the customer base, right, like the folks that we're talking to who actually are using solar today, mostly want more power. Um, a nice to have might be, lightweight or flexible, but actually that's not a format that is compatible with a lot of the existing deployments out there. So you almost have to reinvent the entire industry. And it's hard to make a flexible product cheap. It turns out that you can make a solar panel that's flexible, you can make it efficient, but making it um, making it low cost is really challenging because you have to have a barrier that can block the moisture for 25 plus years, right? And that turns out to be really hard to do with a plastic film. So it's very expensive. And that's going to be a sort of cost floor for flexible solar panels for quite some time. And that makes it more expensive than a rigid solar panel using glass.
Cool. All right. So where are we today, and where are we going in the near future? You've done some pilots. What's the status of the technology? And it sounds like you're getting some interest from industry, but what level of interest? And yeah, so just walk us through where we are today, where you are today, and where you're going in the next couple of years.
Hmm hmm Yeah, so it's funny because if you talk to anyone in the industry who is buying solar panels for these larger scale projects, um, I think what we hear, right, is basically everyone is like, okay, if you have a bankable product, if it's 30% module, 30-year life bankable at 30 cents, right? Like, of course we're gonna buy it. We want everything you can produce, right? There, no surprises there, right? Like, if it's truly a superior product that's higher efficiency and lived at a good price, like everyone wants to buy it. So what's stopping us from getting there, right? It's a sequence of steps of kind of bankability, reaching full bankability, and for a new technology, that's a mountain we have to climb, right? It's factory audits, it's going through IEC and UL certifications, it's going through PVEL's, PQP. It's a lot of these kind of milestones, as well as getting field data for 1 to 2 years in different climates that really proves out the lifetime. So we've started that journey, working with independent engineers, working with customers to field early pilots. So we've announced a couple of those, one with the DoD last year and one with any Plenitude, right, developer in Texas. And those partners are kind of early adopters, right, trying out tandems, fielding them, collecting data, and kind of seeing how it performs in the field. We're quite early on that. Like, there's, certainly I would not be going out saying we can warranty this for 25 years or 30 years and sell this product to you today. But we are seeing a lot of customer interest in doing these early pilots to get to know the technology, understand how you integrate this into a system. For example, because tandem modules give you a much higher voltage than a traditional panel, like you have to figure out the stringing and make sure that everything's compatible at the system level. So there's a lot of learnings to be had, I think, together with our customers. But as we develop that together over the next 2 to 3 years, we expect that the adoption curve from there, as we hit that kind of bankability milestone, get the IEs on board, I think we'll be in a really good place to then scale to kind of full gigawatt scale with good economics.
And what does it take to get from here to there? Like, one of my concerns about perovskites is the degradation. One of my concerns is the contents. There is lead in perovskites. And, First Solar has gone way out of their way to create a closed loop ecosystem, right? Because they do these First Solar panels contain toxic chemicals, which lead is. How do you address the degradation and the toxicity questions?
Yeah, so two separate things. I think on the toxicity, it's really about the amount and the actual kind of risk there. And I would judge the risk in deployment as actually very low. So the amount of lead in a perovskite solar panel, less than a gram per square meter, right? So like, I don't know, a paper clip's worth of kind of lead in a square meter panel. And there have been studies that show that, even if you like fully break a panel in the field, a perovskite panel, not very much of the lead, hardly any leaches out. And even if it leaches out, it gets sequestered in the soil, so it doesn't reach any kind of water supply. So it's really just the amount of it is actually less lead than in a traditional silicon solar panel with solder, right? So it's just like from a sheer amount and likelihood of actually like reaching people and being dangerous, I think it's very low. And so I think the lead issue it's more about how do you protect your workers in a factory, for example? And that's just about engineering controls and safety measures rather than so much fielding these panels. I think it's a very low risk in the field. So that's my perspective on the lead side. I think degradation is a big question. It's always been perceived as sort of the Achilles heel of perovskites, right? So it's a very fair question and fair concern. It's definitely the biggest thing that we've focused on for the last 10 years. Swift has been focused on, durability and reliability of the perovskite, plus how do you scale it up, right? Academics focus a lot on efficiency, hitting new records. Of course, the industry has to focus on scaling it up and making it stable. So our approach is kind of twofold. One is starting out by making the perovskite itself as stable as possible. So that's engineering the perovskite composition. For example, the perovskite itself it has a bunch of different elements in it. It's not just a silicon, like a rock, right? Silicon is one material, one atom. Perovskites have 3, 4, 5, 6 components in it. So you have to get the proportions right to make a stable perovskite. You have to design the solar cell, not just the perovskite, but the thin films on top and below it, to make the whole stack stable so that ions don't move around in the stack and react with other layers. So we do this kind of engineering at the cell level to make the cells stable. And then we integrate it into a panel. And the panel itself, you have to properly stabilize it, meaning choose the right encapsulants, choose the right stringing methods, choose the right parameters for actually laminating this thing. The right architecture to make that perovskite cell that's stable on its own, stable in a panel. So that combination, those two steps, let's say, are really the sort of like the core of making a stable perovskite solar product. We've made tremendous headway on the first one. I'd say 1000x improvement in the last 2-3 years. Dramatic improvements on how to make the perovskite cell itself very stable. And we're very confident that that's on the right track to reaching those 20, 30 plus year stabilities, lifetimes rather. The second part is what we're actively de-risking. And that's what I would say we haven't solved yet. We've have a very good trajectory to getting to that kind of lifetime and matching the cell level stability. But that's why we're doing all this field data and iteration on the package itself to figure out basically how do you get to those lifetimes in practice.
Okay. So how close are you, would you say, to having a product that meets, industry standards, which is really, 0.5% of degradation a year? That's the gold standard. How many months or years away are we from having a Swift solar panel that meets that standard?
Yeah, this is not the answer you want, but I think we're already there. We have HJT panels that are going to be there, this year. So, I mean, I say that kind of half tongue in cheek, but the point is that we have, with this Meyer Burger acquisition, we have a foundational technology that's already proven at lowest degradation rates in the industry, like 0.2% degradation a year, right? And that is really the foundation for our product, their next generation Tandem product. So by starting out by serving our customers with that very low degradation rate, bankable silicon panel, we can then layer in perovskites and make the Tandem product as it matures. So we expect that over the next 2 to 3 years, we'll be at a point where that Tandem is approaching full bankability and ready to go into these large scale projects and be financeable. But even if that timeline slips, which we're fully clear-eyed about, that technology development and field proof timelines tend to slip, we still have this proven foundation of heterojunction that we can serve our customers with as we kind of ramp in the tandems.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more. In our last few minutes together, I would love it if we could talk a little bit about artificial intelligence and how it is impacting your business today and how you think it's going to impact the solar industry. At,
Mhm.
you know, at its most basic value proposition, I think of artificial intelligence as an army of geniuses in a data center that I can unleash on demand on whatever problem I'm trying to solve.
Mhm.
And I know we've not necessarily achieved true super intelligence where the AI is smarter than every human on Earth, but we have achieved human level performance in some disciplines now. And it's probably just a matter of time before the AI is smarter than and equally as capable than every human on Earth. And then you do have this world where you could have an army of geniuses in a data center. Does that army create better technology for Swift Solar while you sleep? Or how are you guys leveraging AI today?
Yeah, I'm glad you brought up that topic. It's a fun one, right? Like we're all using ChatGPT and Claude and Gemini and all these tools. I think it is going to be transformative. And there's a lot of like debate out there about like, okay, when is AGI happening? When are we actually going to hit that mark? And I think over the last even 3 to 5 months, like at least in Silicon Valley, it's been like just like a huge transformation every week, new and new kind of benchmarks being broken and new models being released that kind of really transform what you can do. So I personally am at a point where I kind of feel like AI is already like better than most human experts at most fields most of the time, right? So it's like already kind of like a practical AGI in many ways. But what we're seeing is that for at least the day-to-day operational use cases, right, you're still seeing like human experts, human operators. There's this idea that it might just replace everyone, but I think right now what we're seeing is that it really just gives everyone more leverage, and you end up you're working harder than ever, right? But there's always this kind of like last 20% that you need the human expert to really get the full value of the AI from. So that's just like kind of the day-to-day how we operate as a business side. I think there's a unique piece here with this kind of manufacturing and technology development where there's an opportunity to really accelerate how we do research, how we advance these technologies. So for 5 years, 5+ years as a company, we've been working on setting the foundation, collecting all the data that we can from the lab, from the kind of process pilot lines, from sort of all the data that is needed to run, basically use a kind of more traditional AI, let's say like machine learning, to iterate faster in our experimental process, right? So to do science, right, to do R&D, we're talking about designing experiments, executing those experiments, collecting data, and analyzing it, right, and using that to inform the next experiment. And you can short circuit that cycle. You can accelerate many pieces of that by using machine learning on data, right? So we're doing things like developing AI co-pilots internally that can essentially be sort of supporting scientists, and in some cases even replacing scientists in designing experiments or analyzing the data. In some cases, skipping the experiment altogether and actually projecting forward. So all those things are kind of in the early innings. But I think with what we're seeing, the trajectory of what we're seeing today, I think in the next year to 2 years, it's going to be kind of a transformative opportunity for us and for the industry to move things faster and faster.
And when you think about the race that the US and China are in, for example, to achieve superintelligence, because it does seem that whoever gets there first could have a big economic and or military advantage. How do you think about that, and what is keeping you up at night about the AI race?
Oh gosh, so much. I mean, that scares me a lot. um, I think this is above my pay grade, right? Like how AI is gonna, transform geopolitics, and I guess I've sort of done the armchair reading on how superintelligence might come to be, right? And it is really scary to think about how, the first major, governmental entity that actually achieves sort of super intelligence is going to like basically achieve takeoff and like kind of be the dominant force, forevermore. So there's a clear like kind of imperative, I think, for the US, for, democracy to sort of get to that point first. Um, that said, I think there's clearly like a strategic race here in terms of both like how do we advance AI and how do we build infrastructure that allows us to do that. And I think China has done an amazing job laying the foundation for that over the last 10, 15 years with their domestic industry, electrification, solar batteries, all the kind of foundational technologies that allow you to really train AI at large scale and really deploy it across the industry and economy. So I think we're coming at this from a place where, if you've looked at a solar kind of growth curve, right, China is like far surpassed the US at this point, far surpassed the whole rest of the world.
Right.
US still pretty flat, growing now, but at a much slower pace. So I think we're kind of coming from behind, and it's a funny thing. We're now like kind of an underdog in this race to really achieve this world-changing technology and all of the supply chain underneath it, starting from the energy, the solar, that's going to be a huge foundation for that, through chips and chips, compute, data centers, through kind of models. So yeah, it's a really important and challenging race ahead.
And since you were an industrial manufacturer, if you had the ear of the next president of the United States, what seeds would you plant in terms of priorities for quote unquote good industrial policy? Because I do think industrial policy matters. And the turbulence that we've seen in the last couple of years, while not life-threatening to the solar industry, they certainly have caused turmoil, and they have caused a lot of grief for the wind industry, for example. We've been relatively buffered comparatively. There is a mini boom going on in solar, which is going to be followed by a pretty significant bust in especially, I think, the DG markets. But if you could speak to the future leader of America, what advice would you give them that would help companies like Swift be even more successful?
I think you hinted at it, and the number one theme is a steady hand, right? So I think consistent policy is really what is needed to drive the kinds of investments and the kind of industry behavior that we all want to see, right? Which is consistent, sustainable growth throughout the supply chain. It means manufacturing jobs here at home in the US. It means installations happening at a steady pace. It means every part of the supply chain kind of healthy and growing. And you don't get that without consistent policy. So I think there's something to be said for kind of China's playbook, and they executed it to perfection in some way, like 15, 20 years ago, starting 15, 20 years ago, and have like carried it out with every 5-year plan since, right? Which is like really saying, here are our strategic industries, right? Various parts of the energy industry, electric vehicles,
Robotics.
AI, robotics, yeah, all of these pieces of this like kind of a new electric era industry. Like I think China has really like I think done a good job of building it up strategically. And you could say like, okay, what's good industrial policy? Is it really just what's effective industrial policy? Because if it's all about effectiveness, they've done a pretty damn good job of that, right? So you could say like, what do they use, right? It's like incentivizing local manufacturing with low cost land and labor and electricity, right? It's central government incentives, it's tax incentives, it's export controls, it's tariffs on imports. It's all the same tools that we've kind of been using piecemeal and more recently kind of bringing it together, but done consistently over many years and still applied today, even though the industry is already in China is already kind of global dominating. So I think there's sort of something to be learned from that. And if you can do that consistently and make it very clear which industries matter and how you're going to support them over long periods of time, that's what's going to drive, I think, long-term success for the US.
And what do you say to people who, like myself, honestly, who go, well, I love American manufacturing, but we are no longer a manufacturing economy. We are a service economy, and we're asking a lot of our workforce and our infrastructure to pivot the way we truly need to catch up to China when it comes to, for example, growing our grid, whether that's coal, nuclear, solar, wind, or whatever, right? Like China's installing solar 8.5 times as fast as we are in the US. And I consider that a strategic advantage for China.
Hmm.
But do you think America has the chops to become a manufacturing economy again?
Yes, I believe that. I don't know if I'm in the minority there, but I think we have to. It's a strategic imperative, and absolutely, I agree that China has really taken the lead there and is like really showing us just how how effective they can be, right, at making this kind of thing transformation happen. Um, but I would say that there's no alternative, right? Like the U.S. wants to stay relevant, needs to stay relevant. I think it's a good thing for the world for the U.S. to stay relevant in cutting edge energy technology, and it's the U.S. has done big things in the past. I think we shouldn't forget that, and I think it is absolutely critical that we continue to do big things. I think for the good of the world. I think one thing that is easy to forget is sort of that manufacturing is not just about making the stuff today. It's about having the capacity to make the better stuff for tomorrow, right? So when you lose manufacturing, you lose the upstream, the R&D, the innovation capability, the equipment ecosystems, the supply chains that allow you to actually quickly and in a versatile way build new technologies, new industries, new opportunities, and advance the science that underpins all of it. So I think we have to be cognizant that we have actually given a lot of that up, and it really is time to rebuild that. We need to rebuild it to stay relevant in this century.
One last quick question. Do you think we will have data centers in space?
Do you think we'll have data centers in space?
I want to believe that we will because it is so much more efficient to do that.
Mhm. Mhm.
Uh, can we get stuff to space cheap enough to realize that and make it an economic reality? I don't know. Like, that's economics drives so much, and it sounds expensive, but given how slow we are at building big infrastructure here on Earth in the US, it might be faster to do that. I don't know, but I'm just curious. Like when you think about that, I mean, people like Elon Musk, who are like probably 10 times smarter than me, thinks that it's going to be a thing in 5 years. And who am I to tell Elon that he's wrong? I mean, he's been right a lot in terms of skating to where the puck is going.
Mhm.
But is that going to be a thing?
Yeah, I mean, I think Elon
It's
has
okay
an
if you're
incredible.
wrong. I mean, we're just
No, no, no.
guessing.
I no, I, it's a great topic. I think Elon has a great track record of being the one shooting the puck, right? And I think he has an incredible set of resources and capability to actually direct where we go. Um, I think that it's going to be a thing. I mean, I think there's going to be data centers almost everywhere in some sense, right? Like there's going to be inference data centers close to consumers, close to cities, and there's going to be
Yeah,
data
that's the
centers
other
for
story.
training.
DG
Yeah,
data centers, like
yeah.
home builders are exploring building data centers with new homes.
Yeah,
Um,
that's super distributed. I think to maybe some of that could happen local, really local inference. I think there will be data centers. I think the physics is challenging but solvable. The techno-economics, let's say, like the cost structure. I'm not an expert on that, but from what I have seen, I think it's certainly plausible that as launch costs come down, as our ability to develop these like big radiators in space like improves, and as NVIDIA releases more radiation hard GPUs, I think like the it's a matter of like, do we choose to do it, right? Are we choosing to build the industrial capabilities that allow us to make that possible and then drive the cost down? And I think there's nothing fundamentally stopping us from doing that. Whether it's going to happen in 5 years, 3 years, as some people hope,
mhm.
I'm less confident, but I feel like it will happen. It's just a matter of time.
Hey guys, are you a residential solar installer doing light commercial but wanting to scale into large C&I solar? I'm Tim Montague. I've developed over 150 megawatts of commercial solar, and I've solved the problem that you're having. You don't know what tools and technologies you need in order to successfully close 100 kW to megawatt scale projects. I've developed a commercial solar accelerator to help installers exactly like you. Just go to cleanpowerhour.com, click on strategy, and book a call today. It's totally free with no obligation. Thanks for being a listener. I really appreciate you listening to the pod. And I'm Tim Montague. Let's grow solar and storage. Go to Clean Power Hour and click strategy today. Thanks so much. I want to thank Joel Jean for coming on the show today, and check out all of our content at cleanpowerhour.com. Subscribe to our YouTube channel, but you can get this content anywhere you listen to podcasts. And the most important thing you can do to help others find it is to tell a friend about the show. There are so many thousands of people who do not know the Clean Power Hour exists. So please tell a friend. And with that, Joel Jean, how can our listeners find you?
I'm on LinkedIn. I'm on X. They can reach out to me directly by email. You can find different email addresses on Swift Solar's website at swiftsolar.com.
I'm Tim Montague. Let's grow solar and storage. Thank you so much, Joel.
Thank you, Tim. Appreciate it.